My name is Malcolm Dyer, and this is my A4 presentation on biomechanics, where I'll be going through inertia, conservation of energy, and momentum in detail. At the end of this PowerPoint, I will have summarized all of these topics and will have demonstrated their use in sport. Firstly, inertia is a concept, not a measurement. It is a system that resists the motion of an object. This tendency is connected to the mass of an object. Therefore, if the mass is bigger, usually the inertia is greater. This is part of Newton's first law, which states objects don't change their state of motion unless acted on by a net external force. This is a crucial concept that is heavily involved in sports that involve the movement of an object. An example of this could be seen in ice hockey, as the puck is stationary and will require an external force strong enough to outweigh the inertia for the object to come into motion. The same thing could be seen in football, where the ball needs an external force to act on it to overcome the inertia for it to move. Without inertia, objects would not have resistance. Another example of this, when inertia comes into play, is through two American footballers. The one on the left clearly has a greater mass than the one on the right, which correlates towards the athlete's inertia. If the player on the right was to tackle the one on the left, it will be much more difficult to overcome their inertia and change the direction if it were to be on the other way around. So what is affected after inertia has been overcome? Firstly, we can use the example of an American football being kicked. When it has been kicked and the inertia has been overcome, the ball will have a change in position. Secondly, using a sporting example of a cue ball being hit, the cue ball's inertia will be overcome and its velocity will be increased over time and cause acceleration to take place until it reaches a maximum point and will begin to decelerate. Lastly, if a football was moving towards a striker and they kicked the ball in the other direction towards the goal, the ball's inertia will be overcome and the ball would have changed the direction it's going in. Therefore, change in position, acceleration or deceleration, or change in direction could all occur after inertia has been overcome. Next up is conservation of energy. As we know, energy cannot be created or destroyed, but only transferred. Conservation of energy is the amount of energy that is stored within an object or person that could potentially be transferred. This will allow for the analysis of mechanical efficiency, as we can work out how much potential force an athlete could expel in a period of time, which will demonstrate how efficient it is. Additionally, it can also be used to design sporting equipment, as the designers will be able to see how much force will be able to withstand or to transfer. They can specifically make it for that purpose. A sporting example of this could be through a bench press, preparation versus its execution. Within the preparation phase, the athlete has a conservation of energy of 200 newtons. This is then expended and transferred into the weights. Lastly, momentum is the amount of motion an object or person possesses at a given time. This is another vector quantity, and it can be found through the formula P equals mv, or momentum equals mass times velocity. Momentum is found as a conservation of energy that keeps an object or person from instantly stopping when in motion, as they will have to overcome momentum. Sporting example of momentum comes into play within sport could be through a hurdle race. If a hurdler is going at a speed of 8 meters per second and they have a mass of 50 kilograms, they will have a momentum of 800 newtons. This means that they will not be able to completely stop straight away, as they will have a lot of momentum going in the direction they are running and jumping. This also allows them to use their momentum as an advantage when jumping, as they are able to move forward whilst doing so. Thank you for listening.